Okay, I have my series connected circuit still up here, but I'm going to take it apart and see if I can select a bunch of things and delete them. So now I would like to connect a parallel connected circuit. So what I'll do is I'll drag and drop just two resistors for right now. And I would like to put some ammeters into the circuit so I can see the current divide as it goes through these different parts. Okay, so let's give this a try. I'm going to use my wire tool and connect the dots here, and also down here and across the top. Okay? And I'm going to just kind of leave things where they are and come up to meet them there. And also down here. Okay? So let's change these resistor values. Let's make them low, like 100 and 100. Okay. So let's look at the numbers here. Let's change the voltage to 100 volts. Okay? So if I have 100 volts out here and 100 ohms, I'll have 1 amp, and you can see that right here. Well, I took my switch out, so I can't turn it off. Okay, that's fine. I also have 100 volts at this point in the circuit, so I have an amp right there. So notice that I have a total of 2 amps from the battery, and it splits right here because these loads are connected in parallel, so they divide the current based on their resistance. Okay, so let's change this from 100, let's make it 50 instead. And as you might imagine, more current goes through the 50 than the 100 because the 100 volts from the power source is applied to the 50, and I is V over R, 100 over 50, which is 2. So if I lower this even further, let's make this 10 now. Now I have 10 amps, and I still have 2 amps, a total of 12 amps, right? If I go too low, I'm going to have a very high current here, and things will actually start to burn up if I'm not careful. Of course, it won't burn up in a simulator, so let's take it down to 1. Now I have 100 amps. And let's see if I can go below 1, like 0.1. Now I have 1,000 amps. So obviously it's doing the math. The math is correct, but with 1,000 amps through a resistor, it's going to get like red hot. Okay, so in real life, these parts have limits to what they can do, but in a simulator, there's I guess no real practical limit. So it's nice because you can't burn things up. It's not a real part, but you can see how things happen here. So let me just add one more resistor, and then I have to stop because I'm running a little long on this. So here's another resistor. I'll type W, and let me connect these dots, and I guess I'll throw in another ammeter as well. That right there. W for wire, and here we go. So as soon as I connect it, still have 2 amps here. 100 over 50 is 2. 100 over 50 is 2. 100 over, let's change this to something else, like maybe 100 ohms. So 100 volts over 100 ohms is 1 amp. So my total is now 5 amps, and sure enough, it's 5 amps over here. So these parallel devices here are just drawing more and more current from the power source. Um, if I keep adding them, the current goes up. So as the current goes up, the overall resistance drops. Okay, so that's how they work. Parallel circuits are like lighting systems in buildings. They all have 120 volts across them, so they can all operate correctly. So that's a parallel circuit.